Hey math fans, we're on section 2.2.3. Let's get started. This section is about the average rate of change. The average rate of change of a function is the rate between any 2 points on the graph of a function. It measures how the quantity changes over a given interval. So it's going to be between 2 points, and it's really just going to be the slope between those 2 points. Now remember, we did average rate of change with a linear function, and it's quite boring because the slope of a line remains constant. It's always going to be the same number. But in this section, we're going to be working with quadratics. So the rate of change for a linear function is always constant, but we're going to see how it's very different in a quadratic. Example 1, calculate the average rate of change for the function f of x equals x squared plus 6x plus 9. And they have to give you this part, the domain, between x equals 1 and x equals 3. Because all along the graph, it's constantly changing. So we're going to basically figure out what's the slope in between these 2 points. So in order to do this problem, though, we need those y values. In order to use the formula, we need to figure out the y values. So we're going to evaluate the function first. First thing we'll do is let's plug in that green point where it says x is equal to 3. We plug in f of 3 into the function. We get f of 3 is equal to 36. Then we will plug in and calculate f of 1, and we get 16. So now we have, really, what's the slope between 336 and 116? So in order to figure out that slope, we will use the slope formula, or the rate of change formula, which is the difference between the y's over the x's. Now I usually put the x's in first. So if we go 3 minus 1 in the denominator, that means we're going to be doing f of 3 minus f of 1, or in other words, 36 minus 16 in the numerator. And then we're going to divide that by 2, and we get that the rate of change is 10 between these 2 points, positive 10. So basically, on average, in between these 2 points, even though it's constantly changing in a quadratic, between these 2 points within this domain, on average, the y values are increasing by 10 as the x values increase by 1. So let's use the graph of this function to calculate the average rate of change between x equals negative 3 and x equals negative 2. So let's locate those points first. And then in order to use the rate of change formula, we're going to need to figure out, well, what are those y values? So it looks like at negative 3, the y value is 2. And at negative 2, the y value is negative 1. So there's our rate of change formula. So we're going to plug in the y value for negative 3 first, which we said was 2. And then the y value at negative 2 is negative 1. Now, we have to really be careful here because the slope formula has the subtraction symbol. So our rate of change is going to be 2 minus negative 1, which is really 2 plus 1. And then the denominator is going to be negative 3 minus negative 2, which is, again, addition. So be careful. So our final answer is going to be negative 3. Example 3, for the function g of x equals quantity x minus 3 squared minus 2, is the average rate of change greater between x equals negative 1 and x equals 0, or between x equals 1 and x equals 2? So we're going to need those y values again. We're going to need to do both rates of change. So let's calculate these y values first. So let's take a look at the domain between negative 1 and 0. So again, we just substitute those numbers in. We figure out g of negative 1 is 14 and g of 0 is 7. Now we can do the rate of change in between those two. So we're really looking at 7 minus 14 in the numerator, and then from negative 1 to 0, it's really an increase of 1. So we get 7 minus 14 over 1, which is negative 7. So on average, the y values in this domain are decreasing by negative 7 per 1 unit of x. Now let's take a look at the other domain. How about between 1 and 2? So we need to find g of 1 and g of 2, and then we're going to plug that into the average rate of change formula, and we get negative 3. So we have the two different rates of change. We got negative 7 and negative 3. So at the very end, we'll say since negative 3 is greater than negative 7, the average rate of change is greater between x equals 1 and x equals 2. And that's going to do it for this section. We'll see you in class.